Hello, this is MATH1131 and we're having a look at some calculus problems. This one's from chapter 3, question 6. And in this chapter, one of the key ideas we're looking at is a theorem called the intermediate value theorem, and we're going to use the intermediate value theorem to solve various problems. This one here asks us to show that e to the x is 2 cos x has at least one positive solution. At least one positive solution. Might have a look at the picture firstly and see what the graphics tell us a little bit about this problem. So 2 cos x is a function that's going to start up at here at 2 and it's going to wobble along. It's going to be a normal cosine curve, but that'll take the value 2. And e to the x comes in from here, goes through 1 and then goes up quite steeply up to here. And so in fact, we can see in the picture it's going to have exactly one positive solution if we go back in the positive direction. By the way, if you go back the other way, if you look at this the other way, in fact it's going to have infinitely many solutions back on the opposite side. But all we're asked here to show it's got at least one positive solution. So we can see roughly it's going to lie there. Now the graph is just to give us some idea of what's happening. The graph doesn't count as a proof of this, and so we need to use our analytic tools to prove that there is such a value. By the way, there's no hope of trying to explicitly find what this value of x is where they meet. It's impossible to algebraically extract x out of here. You can try taking logs, you can do all sorts of things, but you won't get anywhere. You can get approximate values to this using Newton's method that you would have done back at school, but just trying to use algebra to isolate x here is not going to work at all. Now I like to do these things as follows. I want to get a function. If I want to use the intermediate value theorem, I need to get a function. So I often look at the difference of the two. So I'm going to let f of x equal e to the x minus 2 cos x. E to the x minus 2 cos x. I want to get a function, and that's measuring the difference between the two. So that number is going to be, for example, that difference or this difference as I move along. And at that point, the difference between the two will be 0. So I'm trying to find a value that makes f of x equal to 0. And I'm going to look at this on the interval, and I need it to apply the intermediate value theorem, I need an interval. So obviously I'm going to choose 0 as my left-hand point of my interval, because I'm only interested in x positive. And I want to get another point that is easy to work with. I want to get another point that's easy to work with. So I'll probably choose the first 0 here of this cos function. Because we can see in the picture's useful. The picture gives us a little bit of help with the problem. I can see in the picture that this 0 is somewhere between 0 and pi on 2. And so I'll take my interval to be 0 pi on 2. Now in order to satisfy the requirements of the theorem, I just have to note that f is continuous on this interval. I don't need to write half a page essay as to why it is. This is an exponential function, continuous everywhere, that's continuous everywhere, this is continuous. You don't need to write an essay, but you do need to mention it. You do have to say something here, it is continuous, that's important, because if the function is not continuous, then the theorem doesn't apply. So don't forget to put in some words in here. F is continuous on that interval. Now, all I need to do now is check f of 0 and check f of pi on 2. And I'm hoping that these have opposite sign. So when I put 0 in, I get e to the 0 is 1, cos of 0 is 1, and I get minus 1. On the other hand, if I put pi on 2 in, I get e to the pi on 2, cos of pi on 2, 0, and minus 1 is negative. And whatever this number is, it's some funny number on your calculator, but whatever it is, it's certainly positive. So f changes sign. At one end it's negative, and at one other end it's positive, and it's continuous, so it has to be 0 somewhere in between. So therefore, by the intermediate value theorem. You can abbreviate it as IVT, but you must mention it by intermediate value theorem. F has a 0, it's a function, at some point, at some real number, alpha is somewhere in the interval between 0 and pi on 2. So that's going to be my alpha in there, where the two are opposite, i.e. that says f of alpha is 0, and that means e to the alpha equals 2 cos alpha. And so alpha is the solution of this. So therefore, the equation, conclusion at the end, has at least one positive solution, which is the value we called alpha. We can see from the picture that's probably all it's got. It only looks like it's only got one solution in the positive side. And that would take a little bit more analysis to prove there were only one solution of this. We're only asked to prove it's got at least one, and we've found one, and so we've answered the question. And so that's the end of the problem.